Uh, Welcome back to my channel. It's been a while since I posted a video. Basically, I was engaged with my personal work, so I could post a video for about a month or so. But also, the weather has been horrible. First, there was monsoon, and then there was a hot summer. So, anyway, s- uh, last time when I explained about my chance discovery of 119, let's say, chance discovery, right, of 119's importance, in which I told about my first test with 119. That was basically Planck's constant. I started with the Planck's constant, which worked out to be H worked out to be 119 m by C, where m was a mass of proton. Right? Second time, while dealing with G, trying to convert G uh, into 4 pi terms, so that we can compare Coulomb's law and Newton's law of gravitation, universal gravitation. I came across this. Then again, third time, I said, while computing the acceleration due to gravity, it turned out to be 4 into 100 into uh, 119 into 1.67 into 10 raised to minus 27. Or rather, will not take this one, basically because for this we have to take sun's mass, right? This, these two together make 200. This this whole thing I divided by c raised to 4, or 81 into 10 raised to 32. But last time I was in hurry and I overlooked one fact, that I told you that without this 100, I gave you this figure, in the sense 4 into 119 into 1.67 into 10 raised to 30 by C4 will give you 9.81. Basically, I took calculator and multiplied 4 with 119 and 1.67 and divided it 81, and I got 9.81, which was rather, it missed by a factor of 10 raised to 2. It was rather 0.981 it was, but I mistook it for 9.81. So yeah, that's the same. And this change got me thinking, why this extra 100? All the while, I have been explaining about these cubes and the pi r square here, the whole thing giving pi r, uh, 4 pi r square, and the everything together, the volume being 4 thirds by r cube, right? I always explain about this. You might have got bored with this by now, but still, it's central to my theory. So, anyway, I thought this 4 pi r squared, I was trying to make everything look like this 4 pi r squared here so that we can use Gauss law. Gauss law says mass by mass rho is given by mass by for the surface area, right? So this 4 pi r squared is the surface area of a sphere. So I was concentrating on this 4 pi r squared, and in that calculation I mistook this as this. So it went wrong by 10, a factor of 10 raised to 2. So that is basically whatever I took into 100 gave me the acceleration due to gravity. So now that got me thinking, and I always used to have one idea at the back of my mind that the structure of the periodic table is somehow wrong. It should be different. How different it should be. And why this 100, factor of 100, why my calculation went wrong by factor of 100, I was a little perplexed. So I went back to my old thinking, and this is what uh, it is basically the, our periodic table. Right? Here we have hydrogen 1, helium 2, and organogen or whatever, it's 118, the last element. Right? Here we have 18 groups, 7 elements. Right? That's how our present periodic table looks like. But you know, you have here you have S groups, S groups, P groups, D group, and here somewhere here you have the F group. Right? And this spreads like this, and there are few what do you call geomet structural uh, uh, discrepancies, kind of. There are only two elements in the first period. There are 6 elements over here, and here. This is the S and this is the P, I think. So we had different number of elements in different periods. Right? 2, this is 8, I think, and then we have 18, 18, something like that. So the structure is not symmetric. There should be a rule where all of the elements should be symmetrically filled. and not like some here, just dump some here, dump some there, do some there, and there's no regular pattern. So instead, what always used to think was we should have a proper periodic table, should have a conical structure. This is called conical. Wherein the doubt I got about this 100, factor of 100, while calculating G as 4 into 100 to 1.67 into 190 into 10 raised to 30 by C4, we got G as 9.1. And I had to add an extra factor of 100 there. I was wondering where from this 100 sprung up. It should have been there. But so, next it made me think that the elements here, if you have watched my video about the quantum numbers, then you would relate very easily. Now, I always used to think like the first group, the first period, one, two, three. Second period would be four, three, five, six, seven, eight. Third period should be like why I'll explain in a while. 12, 13, 14, 15, 16, 17, so on, up to 24. Starting with 25, it will end with 35. Starting with 36, this would end up with 48. Here, starting with 48, it will end up with 63. This will end, starting with 64. I'll tell you why I took those particular numbers. 80. Here, 81 up to 81 up to 99. Here, 100. Starting with 100, it would end with 180. Why I took the particular numbers? Let me explain. The energy always equal to mg squared. This will always travel in the form of a square. It will always form in this form. I mean, as a square only. It won't be a sphere. So if it is sphere, it will be a particle. So this square shape, this square, what are the squares in the numbers starting from 1 to 180, let's say. The first square is 1 square. Second square is 2 square. Third square is 3 square. 4 square. 5 square. 6 square. 7 square. 8 square. 9 square. And 10 square. When we come to 11 square, let's say, this would become 121, right? 11 squared is 121. So this is above 119 and 120. So we need not consider the 11 square because this will go into the next year. As I told you, the what do you call quantum numbers, there will be relative quantum numbers. This will enter the relative reality. So the periodic table, if it is like this, what happens is, let us take the bosons. Bosons are power carriers. The bosons here will be the squares. This one square is, these are nothing but the energy carriers. What energy they will carry? The energy here at the 118, the stable is over. 119, as I told you, as in the Planck's constant, represents H. 119 protons equal to protons by C, mass of, let's say, sorry, mass of 119 protons by C gives you the photon, the discrete packet of the energy, that which is we call basically quantum. Right? This is the quantum. So these bosons will be this one square into this h, basically into h. This will be the square. 2 square is 4, 4 is 4h. This will be into h. Like, will give you the particular boson, right? This is how I visualized. This is ideal situation. Let's say if you want the energy of this particle, this element, let's say 2, the rather ion of helium, how many, uh, how can you get the energy? This one square is a boson, let us say, first boson, let us say. Let us not bother about the types of bosons here. Types of bosons, I mean, name being W boson, Z boson, the uh, photon. Photon, of course, this is photon. And these bosons are comprised of these many number of photons. That's my theory. So, yeah, each will have a name, like W boson. Let's say, for example, this could be W boson. This could be Z boson, and this could be yeah. So such names we can give them later. These could be the blue ones, and the first name will be weak golden. W, Z, and photon. We already have photon here. Uh, blue. So let us not bother about the particular names right away. These are given by this square, the square, the square of this first energy carrier times photon. That will be each boson. And let's say this helium. Helium will have two ones. 1 into 2 is 2 equal to 1 into 2. Similarly, 3, if you want boron, then 1 into 3. 3 photons, 1 photon, 2 photons, 3 photons. Similarly, let's say you have something like 17, then you will have 116 plus 1, that will give you 70. The one boson which has a power of 16 plus 1 photon will give you 70. You can do the same thing any number of times. Let's say there is a 99, let's say 99. 99 will be 81 plus um, 81 plus let's say which square is the nearest 16. If you take, how much you will get 7, 96, and 97 plus 1 plus 1. This is how we will implement these many programs. The boson having 81 photons, one number. Boson having 16 photons, one number. And here 2 into 1, photons, 2 photons, simple. So you can as well come up with some kind of what do you call the instead of binary. Binary we have binary, right? Powers of 2. Similarly, you can come up with a system where you have powers of 81, 64, 49, all the squares basically, all these squares. If you come up with a system similar to binary using these bosons, then you can come up with a combined formula which will give you something like, let us say, you call this W boson. W plus 16 is, let's say, uh, 4 boson, I will call it right now. 4 boson, 2 photon, 2H. So we can come up with a simple formula like this that would indicate, instead of binary code and I mean ternary code and all that stuff, we can as well come up with a code for these bosons and define a, an atom. The energy. You can compute the energy, total energy of that particular atom. So I'm not accurate with the atom, but the ions. How many ions it will leave? How many protons? How many photons it will leave? Will be given by this formula. That's something I came up long back because this makes more sense than having this haphazardous periodic table, rectangular periodic table, where you have to push some of the elements down into a block, and some are here only two are alone on the top, and six, 2 and 6 are separated. There are only two here. There are 6 here. That's awkward. I mean, that's not a very symmetric table. So, but instead, if you come up with such a table, which has the first the energy carriers, the bosons, I would call it the bosons, 1, 4, and all the squares basically. You start with 1, 2, 3. If you have to come up with energy of any other uh, digit what do you call element in this particular period, then you have to just simply take this 4 plus 2 photons. 4 plus 2 will give you 6. Very simple way of coming up with energy of the elements. So that I call it a conical periodic table, which will be very useful for us, I think, and uh, that will naturally have repercussions on other things, right? Now that I have explained the importance of these four uh, bosons, having that kind of structure for periodic table, I will now show you how uh, I'll show you how Now this makes sense. Acceleration in gravity. Why my calculation went wrong by a factor of 100. I will try to explain that now using the same table. Now, this G is equal to earlier, as I told you, I took 4 into 119 into 1.67 into 10 raised to 30, let's say, divided by 81 into 10 raised to 32. That is nothing but equal. And where I went wrong was there was a factor of 100 percent here. So this 100, now we can very easily explain why we have to take, we have to include this 100. This 100, as I just now told you, showed you, this is 10 square. Okay, and the G, this this is where we are computing the G, thinking that it is the surface area 4 pi r square of this 4 pi r square is basically the kind of gravity. So you have to take this four such 10 squares. Now you have to take four such 10 squares, and this being 119 into 1.67 into 10 raised to minus 27 being the photon, such similar objects we are taking 10 raised to 30 here because it is sun's mass. This is sun's mass, and dividing it with 81 into 10 raised to 32. Now we will have perfectly 9.81, meaning this whatever this gravity is, it has such four bosons. This bosons represented by 10 square. Whatever boson represents 10 square, such four bosons, it actually this gravity will contain. So I went to such length to explain all this. It's not just because of this. I always used to think this periodic table to be conical, and there are a lot of uses having such a periodic table. And fortunately, I went wrong by factor of 10 squared here, and I thought it over, and I found that this could be the reason why we should take that square. Yeah. It may sound fastidious for some, no doubt, but you know, going by my previous theory of what do you call relative quantum numbers, as opposed to ordinary quantum numbers, we had to take more than seven principal quantum numbers there. But here, if you divide this like this, these are the principal quantum numbers. Right? If you take these as principal quantum number, the 10th quantum number will automatically give you 2. graviton. I know what I want to call it graviton because let's say G itself. Let us say this. Let us call it G. But if you want to compute graviton itself, then you have to take a similar thing which corresponds to a photon. Right? Here we use the mass of sun for to compute the relation due to gravity. To correct myself, this was the mass of the sun divided by C4, which gave you rather two less decimals here. It went wrong by basically 10 times square, right? So to correct that, I had to include 100 here, and what that 100 could mean is this one. This boson, if you take, then you get this G perfect. So since this it has graviton has is similar to gravity, and then rather people think graviton is uh, gravity, represents gravity. It does, but at a different level. I understand earlier in another video I told you that there is a however here involved. We are basically comparing two different systems, different realms, the quantum realm and the relative realm. And the relative realm, right? So this is fogging again. But I can't help. So I always used to tell you the one thing is 3 to 10 raised to 8 is quantum realm. Fourth dimension of quantum realm. And fourth dimension of relative realm is 0 to 4. That is 81 into 10 raised to 32. Right? So what holds good for this to compute G should hold good for this G. I will call it the T because graviton to differentiate from G, previous gravitation constant. GT, let us say, is a minuscule particle, minuscule particle which is in, uh, in the proportions, right? Um, uh, in the proportions of um, what do you call Higgs boson or other bosons. What is Higgs boson? 125 point something giga electron volt, and this graviton, if you compute the same way, I have come up with another way to compute this thing. Let us take energy of proton equal to mass 1.67 minus 27 into c square equal to 1.67 into 9 into 10 raised to 16 minus 27. If you take 119 of such 1.6 119 protons, let's say proton, If you take it will become 119 1.67 into 9 into 10 raised to minus 11, which is nothing but uh, this will be 200. 200 into 9 is 1800. 1800 into 10 raised to 11. This is equal to 180 to 10 raised to minus 11. These are in joules. So we have to convert 180 into 10 raised to minus 11 by 1.6. 1.6 into 10 raised to minus 10. 1 giga electron volt is equal to 1.6 not 2 into 10 joules. So the same thing I'm taking here, dividing these joules, energy in joules, with this thing, we will be getting 111, 111 giga electron volts. This will be the energy of 119 protons. 119 protons, energy will be 111 giga electron volts. So that is one way to compute, come up with something like what do you call uh, graviton. If you want to compute the provided uh, if you consider this as graviton, that will be so much, or um, which is pretty much near 125 of what do you call Higgs boson.